Okay, let's turn down the volume on this. And okay, so welcome to this bonus tutorial. So we're going to talk about OP2. And this can be pretty interactive. It'd be more interesting if it's interactive. So ask questions, tell me what you're thinking of for OP2. Okay, so OP2, one part of what you're doing are design achievements. Okay, so often, do you already know what you're going to do for that, or who's thought about OP2? Still not on your radar? See, I haven't really thought about it yet. Okay, so that's fine. I've thought about it, so I can tell you my thoughts. Actually, before we do this, how's milestone 4 going? Or is everyone here the people who are on top of milestone 4, or the people who are just gone, forget milestone 4, I better work on OP2? How's it going? In progress? It's working? Not exactly where you want to be, or what? Who has a working milestone 4 solution? Sort of, yeah. Okay, so some of you. Okay, so you can ask me questions about that too if, after we go through this. Okay, so one of the things you're doing in OP2 is your design achievements. So you start with hopefully grab attention. So try to come up with an opening that's a bit interesting. And then it's up to you to, you're going to talk some about how your map works, what's interesting about it. And we're giving you some leeway there of you decide what's most interesting. Okay, so don't think, oh, I have to talk about everything I did. That's not a good strategy. Pick the things that you think are going to be most interesting to your audience. And we say that we'd like to hear some about the visualization and some about the algorithms. So, but you don't have to give equal weight to each. So if you feel visualization is your stronger part, then you might spend more time on that and less on algorithms, but still tell us some about that. Or you could flip that. And if you have some really interesting algorithms that underlie your visualization, you could say, well, I'm going to talk mostly about those algorithms. Most people don't. There's not that many underlying algorithms, but there are some cases where that's true. Okay, so focus where you have more to say. And then you want to be concrete. So don't tell us that your map is really easy to use, or it's really fast, or it has this cool feature like show us. I mean, we're talking about visualizations. This should be very concrete. A common problem that shows up in some presentations is people will be talking about, notice how we display the following, and it's really cool, but on a screen where your CI and TA are 10 meters away from the screen, is actually not visible. So get far from the screen, see, is it visible? If it's not visible, zoom way in, draw a circle around it, something. Make sure that it's visible, because it's surprising how many maps we'll see where they're talking about all these cool features, but from the zoom level we're at, we can't really see it. You might choose to do a video, so you can pre-record a video. Zoom is an easy way to do it. There are some other ways to do it that I can post on Piazza. If there's some interesting technical approaches underlying what you've done, and there might be, there might not be. So, again, play to your strengths. If you feel you don't have that many interesting things to talk about technically in the visualization, then focus on what it looks like. But there are some teams, for example, that use grids to divide up the space so that they render really fast, or they use something called MIP mapping, where they take complicated polygons that are features and they make lower, less complicated versions of them to use when they're zoomed out. So if you did something like that, you might go, well, that's pretty interesting. I'm gonna show that. And you would try to show it, again, in a concrete way. Instead of telling me that you, for example, make both a high resolution version of a polygon to draw and a low resolution version, draw it. Show me that it's very hard to tell the difference. Iceland, for example, the island of Iceland is about 180,000 points, giving you the outline of the island. So some people figured that out and went, you don't need that when you're zoomed way out. You can make a lower resolution version of that and it'll render faster. So if you happen to do that, that's something you could show in a very concrete way. You could actually show numbers showing how much faster it was when you did that versus not. If you have level of detail modeling, you might show how fast was it without level of detail modeling, how fast was it when you put it in. So that's the, if you have data to back up your claims, so you say your map is fast, show some information about the redraw speed. You have to think of how to present that in an interesting way, maybe a graph, maybe a table. Can be more interesting if you show a before and after. So if you show my redraw speed is really fast, nobody knows, was that hard or was that not hard? Or how did you do it? So if you can link it, you can say, this is the redraw speed we got when we didn't do any level of detail modeling. Here's the redraw speed we got when we did that. Here's the additional redraw speed when we did this other clever thing, like dividing the screen up into grids. And if you didn't do that, don't worry about it. You know, nobody does all of these complicated things. So you just kind of, you decide where are your strengths and spend more time talking about those. Okay, then algorithms. I want to tell you some about your algorithms. And you can pick, you know, you could talk about something from M3, something from M4. You don't have time to talk about everything, and it's probably not going to be interesting to talk about everything. So again, pick where your strengths are, what's going to be show you well. So you can briefly orient the reader. So let's say, for example, for milestone 4, you use simulated annealing, which is a relatively complicated algorithm. So you might go, oh, that's kind of interesting to talk about. It was hard to tune. Maybe it worked, maybe it didn't work. Even if it didn't work, you could talk about it briefly, that, you know, I tried this, but it didn't work. Instead, we found this simpler approach worked better. That's actually interesting. If it did work, that's interesting too. One thing you don't want to do is don't reprise a lecture we gave, which we see sometimes, right? So, you know, the TA or CI is watching slides that that I made basically, and even if they go, well, if they think they're bad slides, they're going to, I hate those slides, bad shows. Okay, so you're not going to do well. But even if the CI or TA thinks they're good slides, they're not going to give you that much credit because they know you took them from lecture. So you can, it doesn't mean you can't use material from lecture. You can, but don't reprise a lecture, right? So you could briefly orient the person saying, okay, let's remember what simulated annealing is. It does this. You might explain it in a slightly different way than I did, a little bit faster maybe, more analogies. And then go into what did you do? Okay, what's your secret sauce? How did you use it? What were the results? And sometimes people come up with fairly interesting algorithms, like different things that they do, particularly for milestone 4. So you need to make it understandable, which is challenging. So that's part of your challenge. How do you use visuals or analogies or flow charts? But you got to keep it kind of high level. If you start getting into way down in the details, remember your CI and TA are not going to leave the room and try to code what you just told them. Okay, so your goal is not to, yeah, they have the code and they can just type it in. Your goal is they go, I got the big picture of that and it seems kind of cool and that explanation was pretty understandable. So what level of detail can you go for where you achieve that? And then, so that Dr. Tallman will have a couple of pictures today about that, like ideas for that, but there's no one answer. This is where you can be pretty creative. And then show us the data. So if you say this algorithm worked well, or maybe it didn't work well. If you try 6 algorithms and 5 of them don't work, that's actually still interesting. It shows your TA that you tried a lot of stuff, you were rigorous in measuring it, and you know what works and what doesn't. And that's also interesting. Okay, but show us the data. So here's an example of what I might show for my algorithms. Okay, so this really comes from our reference solution. Okay, so this is the quality of results that we achieve, averaged over the hard and extreme test cases. And the TA bad solution is actually a random assignment of deliveries. So we just take the original order that was given to us and we visit all of the intersections in that order. First pickup, first drop off, second pickup, second drop off. So that's what, and that gives a pretty high travel time, 400,000 seconds on average for these big test cases. If we change to a greedy algorithm and we use distance to predict how long it's going to take us to go from one intersection to another, and we optimize with that, we get a much better result, about 140,000 seconds on average. If we take that same greedy algorithm and we don't estimate travel time as distance, we get the real travel time using efficient path searches. We get a better result. And if we take that greedy algorithm as an initial solution, but we don't do it just once, we do it several times because it's quite fast. So we call that multi-start. We take the best of several greedy algorithms that are perturbed a little bit in terms of how they make decisions. And then we pass that on to a simulated annealing algorithm that we wrote that makes changes in the order of intersections. We get a better result still. Okay? All right, so what do you think of my presentation of this data? I put thoughts on there, so that's a sign. I'm looking for you to tell me, you know, I guess the best ever. You're like, man, I didn't think anybody could get 100% on a presentation, but you just nailed it. Or you're like, no, there was room for improvement in that. Or maybe there's a lot of room for improvement. Like you just got to delete this and try again. So what do you think of the way I just presented this data? What do you think? Yeah, say it really loud. I'm going to repeat it because I'm recording this too. Because I go to YouTube and I see lots of people watch the recordings, so it's killing our lecture attendance, but it seems like people are getting value from it. So you said there's no context. So we have this, I guess I said QR. Is that the best name? No, I mean, when I was verbally describing it, I said travel time because I can't even bring myself to just say QR all the time because it seems a bit, what is this term? We use it, and you're saying, what is this? You know, I have no context. 400,000 seconds. Yeah, is that meaningful? Do I need to show the actual numbers? Like, is this the best way to show the data? So what would you do? I agree with you. I'm not giving very much context of what these numbers are. They're a little hard to interpret. What would you do to restructure it? Okay. Okay, so give an analogy, briefly explain them. So I'm going to put up these numbers. I got to give more context of what they are. Take my time a bit more. Notice that I did put QR up here. Maybe it's not terrible. I mean, I didn't label this axis, so maybe not visually the best. Anything else? What else do you guys think about this? So I agree with all those comments. Those are good. Those would be good improvements. What do you think? Yeah, yeah, I totally agree. So I've actually undercut my argument here by putting in a really bad algorithm. Okay, this is TA bad. Um, it's a random order, so it's terrible. It stretches my vertical axis a lot. It makes all the other algorithms look just a little different, which is probably not what I want to show, because that's actually what I want to talk about. So I let Excel auto scale the axes for me, and it actually kind of undercut my whole argument. And in fact, it was even hard for me to read the numbers off of this. Like, it's so zoomed out that I'm kind of, well, it's about 140,000, and that also kind of looks like about 140,000, and maybe that's a little less than 140,000. So I can't even really tell the person how much better they are because visually it's kind of hidden. So not very good. Any other thoughts on this? Yeah, what do you think? Yeah, this is what Excel chose for me. And in Excel, it was fine, you know, when I'm sitting right in front of the screen, but these are not an appropriate font size for a presentation. So I'm using like almost invisible fonts. So not great. One thing that is probably good, I'm going to give myself a little credit for this, because I didn't have time to break it for this slide, is I put names underneath the algorithms that are probably reasonably good. They might be hard for you to read, so I'll go on to another slide that's a bit better. Sometimes we'll see, like initial, improve 1, improve 2. That's not great. Okay, so when you name your algorithms, give them a name. You can't usually explain everything, but you give them a name that's going to kind of encourage a person to understand what is that. And I did do that here. Another thing I did here, I used a 3D style bar chart. It's not the end of the world, but it is a little bit visually distracting, frankly. Like, I really would like you to understand what the numbers are here. And I think this 3D actually makes it hard for you to see. It's not actually making it easier for you to see what are the real numbers. You got to go, okay, ignore that back blue part, focus on the front blue part. So I probably wouldn't do this either because it looks kind of prettier. And if I was just trying to have a chart that said good, bad, maybe that's fine. But if I really want you to see the numbers, a simpler chart's probably better. Okay, so what about this one? So this is this is the chart I was drawing just as you came in. So there may be a few visual artifacts. So same data. This is exactly the same. What do you think of this one? Do you like it? Is it better? Is it worse? Things you like, things you don't like. So I'm going to come over here and ask you. So yeah. So I should put a title on here. So I've labeled both axes, so you can probably tell what it is. Well, maybe I should label algorithm underneath the x-axis. I've labeled the vertical axis, but I should have some kind of header. Like, what is my point? Okay, so yeah, so I should do something here. It doesn't necessarily have to be a title of travel time versus algorithm. Like, I might be able to come up with a more interesting one. Like a more interesting one might be best of both worlds or combining algorithms, something like that, because that's actually what I've done here. Is our best algorithm over here is actually a combination of multiple sub-algorithms. So maybe that would be an interesting header, like combining approaches best. I've labeled this axis. I didn't put, maybe I should have put algorithm here. Okay, so that might have been good. And then maybe here it's, best to combine or something, some interesting header. I'd probably personally do an interesting header rather than just putting like the name of the graph, because you should be able to, given how well I've labeled the axes, you should be able to figure out what the graph is from that. Notice I've broken this bar, okay? And maybe I should put 2 bars there, 2 little squigglies there. But basically, this is a technique you can use if I want to show random is way worse, but I don't want to stretch my whole axes. I can do that by breaking the bar, but I don't want to stretch everything, because now that I'm zoomed in, I can actually read this off. I can say, well, we initially have a greedy algorithm, far, far better than just using the original delivery order. But we can cut the travel time by about 4% by not using distance as the guiding function of what's close when we're using our greedy algorithm. We can instead use the real travel time. But that's still stuck in a local minimum. And if we take that greedy algorithm, we perturb it by making decisions slightly differently about where to go next, and we take that output, we try that multiple times, take the best of them, we send that to an annealer that swaps intersection orders, we wind up with a significantly better answer yet, another 11% lower. So this would be a better way to show the data. Now, I should also, if I was doing this in a presentation, I should show you what is greedy, what is an annealer. So don't just jump to results like this saying, oh, my CI and TA know exactly what shorthand, I just named the algorithm, that's all I need to do. No, don't do that. Show them some interesting visualization of what does greedy mean, what does greedy with exact paths mean, what does annealing mean, okay? But now this would be the payoff slide of how much better does all that stuff work. Does that make sense? So given that, do you like this slide now? I think this one's pretty good. Maybe you could visually make it more beautiful still, because as I said, I was running out of time. So it's the other thing, I guess, reason I'm showing you this is it's actually quite interesting to see how algorithms compare. And TAs in particular will like this. This is how often research papers are presented. They don't just give one algorithm for a new problem. They'll say, we tried several, and we kind of learned interesting things about this problem by seeing which algorithms work well. So if you've tried multiple approaches and you have data on that, it actually makes for a more interesting presentation. And it's kind of more authoritative, like a person believes this algorithm probably works well because you actually showed me comparisons to other ones. You might show the leaderboard. So it depends if that helps you or not. So here I'm showing relative QOR. Everyone can do that. Just go QOR versus their own solution. I might put some lines on here, for example, to show, maybe this is the TA good. And in fact, that is, right? And I put a line here, and I might show that's the TA moderate. So I might put some references in there, especially if they show me well, right? If I'm actually underneath the good TA solution, you might go, that looks really good. You might show where are you in the end on the leaderboard if it shows you well. If it doesn't show you well, don't show it, right? Just show the relative comparison between different algorithms you did. Does that make sense? If you didn't do a bunch of different algorithms, okay, fine, then don't show this. Think of something else, some other part of your mapper to focus on. But this is an interesting way to describe algorithms. Okay, does that make sense? But I have left out this key missing part of you also, if you're going to go into this, describe what the algorithms are. And yeah, I'm not going to talk about that because there's just many, many ways to do it. But make sure you're using analogies or animations or high-level flowcharts so it's understandable. You can even put additional visualization into your program so that you produce some interesting animation. You don't have to do that, but sometimes that's an interesting thing that you might consider. Okay, so that was all about algorithms. So let's talk about pitching. So another part of this presentation is you got to pitch an idea. Okay, so first, do you do this? Sometimes this is one of the parts of this presentation that some students are kind of some really get into it, some are kind of uncomfortable with it. They're like, What is that? I like presenting data. So engineers, they think of it, I do design, I don't pitch, right? So I'm not this used car person. Um, so engineers do pitch ideas all the time. That's part of why we put it at the end of this presentation. It's going to be an important thing in your career, convincing people to do what you think is a good vision. But we try not to be, I don't know, this picture of used car salesman. So you try to have evidence, argument, data, but it's still got to be memorable, right? If your pitch is just a whole pile of data and you say now people will understand why it's so important, well, you probably failed. Okay, so when might you do this? So starting a company. So I started a company. I had to pitch lots of things to employees that I'm trying to hire, to people that I want to give me money, to customers that I want to buy the product, which doesn't exist yet. So all of those are essentially little pitches, different ones for each group. You may not want to start a company, but if you are starting, you've joined an existing company, that's kind of your other option. You're going to often within a larger company be starting a project or expanding a project, like making arguments of, I got this idea, we should do this. Okay, you got to convince your boss or sometimes your whole management chain to spend the company's money and resources on it. Or maybe it's just that your team should do more. Okay, you got to convince people of that. If you're a new engineer on a team, this is maybe the smallest pitch, but you just have an idea that's just you. You don't really need anything beyond your boss's approval, but you still got to convince your boss that this is a good idea and that she should integrate it into the company's product. Okay, so you want to be good at this. It's always linked to how good is your team. So this pitch being at the end of your op2 after you talk about what you've achieved is actually realistic. You normally don't do a pitch in a vacuum of, I have no idea who you are. You walked in off the street, you tell me about your great idea, it sounds fantastic, here's a bunch of money, or I'm going to join your company. People want to know who you are, what have you done before? So, and there's a saying in venture capital that a great team with a mediocre idea is better than a mediocre team with a great idea. Okay, so team matters a lot because the idea will change. Okay, so you really want the Maple Leafs and not the Pee Wee League, and maybe some years, maybe even want the Montreal Canadiens more. I'm a Canadiens fan, so I can't resist taking slight shots at the Maple Leafs. So the earlier part of your op2 presentation has already established your credibility. What do you know? What have you built so far? So you don't have to repeat that, but that's how these two pieces kind of fit together. Actually, if you're doing a pitch in real life, people are also, they're watching you. So you've told them about how great your team is, how great you are, but you don't say it by literally saying, I am great. You show achievements that make them think you are great. And the energy you bring, the clarity of your presentation or answer is all part of their evaluating the team. Okay? So in industry, or starting a company, ramping up a team in a company, they basically always have an in-person meeting because they don't want to just get an email with the idea. If this is a significant thing, they want to see the people, and they're kind of evaluating those people as they make the pitch. Okay, so a pitch starts with you identify a vision or an opportunity. Okay, so there's some problem that your idea fills. So you gotta highlight that. So when you get to this pitch, the first thing you're doing is what is the problem? And you want to go off and think about this a bit. If you can come up with an interesting problem, your pitch tends to be more interesting. If your problem's not very interesting, it's harder. So think about what might be an interesting problem. And we're going to be pretty, it doesn't have to be that closely connected. Okay, so try to connect it somehow. Say, well, now that we've shown you we're great at software, we're going to go off and build some software to do this. Now that we've shown you we're great engineers, we're going to do this. So we're not going to worry too much about, it fits in exactly with what you've done. Generally, many students go too small rather than too big. We really don't want to see a pitch of, for milestone 3, I got 73% on the unit tests, and I believe with the following enhancements, I can get to 92%. This is not an exciting vision, okay? Don't tell us that. Give us a bigger vision than that. So usually students start with, it's common to go with too small a vision rather than too big. Your TA is not going to go, oh, it doesn't seem to fit exactly into what milestone 5 would be. TA doesn't care. TA wants to see something interesting. Okay, so start with what is the problem you're trying to solve, and spend a little bit of time thinking about that. Brainstorm. I'm going to show you a real problem that. So some years I've been a mentor in the engineering hatchery, which is an entrepreneurship incubator here at U of T for engineers. One of the teams that I mentored was a company called Fuelware. So I was going to show you what they did. So they came up with this idea. All right, so sorry, let me just go through this. So the gap is part of, what's the problem? Who are the people you're trying to solve that problem for? What's the impact? Okay, so Fuelware, their idea was they would make heated clothing. Okay, so electrically heated base layers, so things you'd wear under your clothes, and it would have smart feedback controls. So it would monitor the temperature outside, temperature of the clothing, and it would turn up or down an electric current that went through all sorts of wiring in the clothes, and it would keep you warm. Okay, and the original idea for this was they would sell it to contractors, and when they actually went out and looked, they found there were competitive products for that, right? That there are heavy parkas that contractors can buy, and battery packs from drills and so on would fit into that. So it actually looked like an unassailable market, because there were, these contractors liked using the same batteries for their drills and their jackets. Didn't look like a good idea. So they pivoted. They said, okay, you know what? Sports enthusiasts, let's go for skiing. Skiing, you ski down, you get hot. So you want to turn off this electric heating. Then you ride on the chairlift, you get cold, turn it back on. And feedback, they could do that automatically. That was the idea, okay? So that's it took them a little while to identify the gap. They thought there was a gap in one spot for contractors. They found that wasn't, but there was a gap for skiers. Next, so that's your first thing, find your gap. Second thing, survey the landscape. So survey the landscape is you want to see, are there competitors? Are there similar products? We're not looking for, your TA and CI are not going to write you a check at the end of the presentation. So we're not looking for like a giant business plan that you've gone out and figured that out. But if you, for example, say you're going to make a mapping application that can find you directions from A to B on a cell phone, they're going to say, okay, how is that different than Google Maps, right? So you want to have done your homework and see, are there any competitors? If there are, how are we different? So when Fuelware surveyed the landscape, they did find there was a competitor. There's a company called VentureHeat that also makes base layers that also were electrically heated. So they got to address that. If they're going to do exactly the same thing as VentureHeat, that's probably bad. So you got to think of, if there are competitors, and there usually are, how are you going to differentiate? So where's your gap still? So what they did is VentureHeat did not have feedback. You just turned it on and it stayed on. So they went, okay, for skiers, that's not great. The other thing about VentureHeat is their wiring wasn't washable. So you have a base layer, so it's actually against your skin. You're skiing and doing athletics, and you couldn't wash it. It's actually a significant problem. So they, through a lot of experimentation, came up with carbon fiber that was electrically conductive but could actually be washed. So now their base layer was washable. Okay, so third thing, okay, so we basically found a gap, we've surveyed the landscape to see are there any competitors, and we've differentiated from them. How are you going to address it? So what are you going to do? So they basically figured out they got three things to do. They need to get the base layer and get the wiring in it. They needed to have the hardware that could actually send electrical energy through the heating elements, and they needed to make a custom circuit board and some software. And they needed like a nice case that could be impact resistance, because this is like skiers that can fall down. You don't want to fall down. You break this thing, the current goes through the roof, and it basically gives you burns while you're lying in the snow. Like, you wouldn't want that. So they had to think about all that. So they're basically what they found their key gap that they needed to address. The key technology they needed to work out was feedback control, washable wiring. So they figured out the two key challenges that they're going to have to spend their time on. Okay. And they actually won the hatchery that year. So they made it a Kickstarter campaign. They raised over $100,000 on that. They won the hatchery competition, another $20,000 prize, and they actually made this, and they sold all those feedback controlled heating elements. So it was pretty nice success for them. Okay, so the other thing you want to do in your pitch is make it memorable. So it's not about describing all the technology in detail. If a person walks out and they can't remember your pitch, CIs and TAs do this. So I act as one of the TAs every year. If we can't remember your pitch after you leave the door, then we're going to say, okay, it wasn't very memorable. So what are you going to do? And you can use props. So for example, for this group, bringing in the physical item is good. So try to make it memorable. Okay, so what could your pitch propose? So first thing was like identify something interesting, some gap. So you could propose that you're going to do visualization. So you'll add more data or some specific users. So maybe you'll make a crime risk reporting, okay? Which maybe has some interesting, is that a good or a bad thing socially? You could talk about that. This is an interesting one. So you're getting beyond visualization into modeling. This is a real product from a company called Blue Dot. They built, this is before COVID, they've been doing this now for quite a few years. They built a GIS to predict the spread of infectious disease. So what I'm drawing here is actually airline routes around the world. So their software, basically people input into it infectious disease data for emerging infections, like Ebola, that's actually where they use this a bunch. And they predict where could this spread to and where do we need to take action, because a lot of it spreads with air travel. Okay, this is actually data from the 2014 Ebola epidemic. This map actually uses OpenStreetMap data, so using the same data as you. And it's now this is beyond modeling, this is optimization. So what these numbers are is basically the time to get to a treatment center, a diagnosis and treatment center. Actually, these numbers, I believe, are the number of cases. But basically, they wanted to figure out where they should put assessment and treatment centers for Ebola in order to stop an outbreak of Ebola in West Africa most efficiently. So now they're not just modeling where does the disease go, it's an optimization problem. It's actually kind of related to your milestone 4. Where do you put the treatment centers to minimize the time people need to travel to get to them? And that's a function of where are the cases and the road network and how many treatment centers you can afford. Okay. So those are just a few ideas. And it's interesting to go beyond, I'm going to display this or I'm going to display that. So you can think about some of those modeling and optimization techniques that you could use. But you don't have to focus in on, you can focus in on many more things than that. So it's interesting to read about technology for your career, stay on top of emerging trends. And often where you find the biggest gaps are where things are changing really quickly. So here are a few ways the world is changing. So Mark Andreessen's a famous venture capitalist, and he was the creator of the first web browser. And he has this interesting article that is basically, why software is eating the world. It's basically because software automates so much that it's disrupting a ton of industries. So what's the next industry that might be disrupted? Actually, real estate, frankly, looks like one for me. So if I was starting a company, I would try to disrupt real estate. So you might get ideas from thinking about what could be disrupted by software. Sensors are going everywhere. So we're getting city scale data. How does that change traffic management? How does that change transportation? How does that change delivery? Software optimization of everything. So optimizing how goods move around a city, around the world, in Amazon warehouses. So Amazon has bought, a robotics company that actually had was founded by a U of T Eng Sci graduate. Because they're trying to automate their factories and they need software that talks about how do we organize the pickups and drop-offs inside their warehouses. Machine learning, so self-driving cars, traffic optimization, lots of machine learning algorithms being applied there. And entertainment, so virtual reality and augmented reality where you wander around. So Pokemon Go is an example of a game embedded in the real world. And you can imagine how that could fit in with some of the visualization software you've been writing. Okay, so those are all just ideas, things you might go read that are interesting for you. And you brainstorm, come up with some ideas. So I'd say for this pitch, it's good to brainstorm as a team. Do some reading. It's like APS 111, 112. So I think all of you did brainstorming exercises at APS 11, 112. Is that right? Did they work well or not? Was that a fun experience, or you're kind of like, nah, I'm just curious. So was it so-so? Okay, so so be that as it may, it's a good idea to brainstorm. It's more open-ended even than APS 111 and 112 because you're not just identifying solutions. You're first trying to identify problems. What would be interesting? So create lots of ideas, pick your favorite and refine them. Okay, so let's say you come up with your idea now. So you got your idea for a pitch. So I'm going to show you my idea for a pitch. And you can, so, give me 4 minutes of your time, and then you can critique what I do well and what I do badly. Okay, so about 4 years ago, I was in Xi'an, China for a conference. And one of the things I really wanted to see in Xi'an's the historic capital of China when China was first unified. And the terracotta warriors are in the funeral tomb of that first emperor of China. So I wanted to go see them. And I did go see them, and they're really impressive. However, the thing that was less impressive, there are actually lots of other interesting things to see. Temples, there's a mountain you can climb right by these terracotta warriors. But outside, the air pollution was like unbelievable. This is just a picture, and this is not fog. This is not a day where there's a lot of mist. This is just smog. And it was like that every single day. So my friends and I did not climb this sacred mountain by these terracotta warriors because you couldn't even see the top of it. In fact, you couldn't even see across the patios that were 100 meters or 200 meters wide very well because of the air pollution. So this is pre-COVID. Everybody's wearing masks outside just for air pollution. Okay, so, and one of the things that we did is we could actually tell every day what is the air pollution like and where is it by looking at websites that showed you maps with air pollution particulate counts. So higher numbers are worse, and red is worse than yellow. But above 100 is bad. And on many days when we were there, the numbers were up into like 400s, 500s, which is like really bad, hazardous to your health. So you had to make decisions about, do you even want to go outside? And for us, we're not going to get back. So it's a difficult decision. And you could actually see where some of the pollution is coming from. This is a coal-fired generating plant. And going from the airport to our hotel, or my hotel downtown, we passed multiple coal-fired plants like this, and you could just see the particulates being ejected into the atmosphere from them. So the vision is, how can we make this better? Okay, we don't want people just wearing masks. How do we make the polluters, this coal plant, accountable for the fact that right here we've got an unsafe level of particulates? Well, people are protesting around the world. They're not happy about air pollution and its impact on their health. But how do we go from a general protest about air pollution to a specific one about specific air polluters to put pressure on them? That's where we come in. So we're going to estimate the pollution volume at the source. We're going to take the readings from many sensors. We're going to take photographs, and we're going to train machine learning models, and we're going to figure out where is the pollution coming from. We will estimate how it drifts and spreads. This takes a lot of computation, but it's a known problem. It's what we do for weather. So we're going to look at the wind, which is measured on a local basis, and we're going to solve the mathematical equations that define how you drift with a wind. We're going to make sure that we're accurate by correlating this to the measured pollution at hundreds of sensors on the internet. And then we're going to visualize the results on a map, and that's going to apply targeted pressure about which companies and which polluters are impacting your local air quality, and that is going to gradually make the situation better. Okay, what do you think of my pitch? I'm going to preface this by saying it's not the best. I didn't try the absolute hardest I could, so don't worry. You're not going to hurt my feelings. I didn't try to totally tank it, but there are things in here where I intentionally went, I'm not going to do this quite as well as I could. There may be other things where I unintentionally did. That's fair game too. So what do you think? What do you think of this pitch? Terrible, awesome, some good, some bad. What do you think? Okay, let's see if I get my first marks. Does anyone remember the pitch? Because this is, I told you, if you've forgotten the pitch already by the time you're done, like, it's not great. You sort of remember it? Okay, what do you think? Yeah, I think that's exactly what I would assess that as well. So I'm glad you like the story. It is actually a true story. But the solution, I actually intentionally did it this way because I agree with you. There's a lot of text here. It's probably too much detail. Where am I going with this? So I think that is the weakest part of the pitch. So you had some thoughts? Mm. Yeah. 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 So it makes sense. I think those are all good points. How could I have done this? How this is like this is the weakest part, right? This is like, how am I going to do it? How could I improve this? So you said too much text, and I agree. This is like a wall of text. Not a good idea. Pitch is not about a lot of detail. It's about big picture. So not a great idea here. What should I have done instead? Any ideas? Okay, so basically I'm going to write a couple of this down, a couple of things down here. So mostly I think you like the story, but maybe more text signposts early on, because maybe it's not quite clear what the heck am I talking about. If you don't listen to me, you're not going to get it for sure. So that makes sense. And then there's way too much text and detail in the solution part. What am I really going to do? Right? Should have had more pictures. Does everybody agree with that? So a way that I could have done this that I think would have been a lot better is, let's see, so I got this kind of wall of text. I could have basically said something like this. I could have made a little flow chart, right? So I could have made a little flow chart, which is something like sensors, wind, drift, models, visualization, and maybe social media alerts. Okay, so if I put that in, and maybe I put a little picture beside each of those things to make them a little more concrete. Show me a picture of a sensor, show me a picture of like, a weather system model, because that's what I'm talking about when I talk about wind and drift models. Show me just a picture of what my map might look like and a social media alert. It's more concrete, it's less overwhelming. You kind of get a picture of what does this product look like without this big wall of text and all this detail that seems kind of irrelevant, right? We don't care that much about exactly how you're going to do it. The truth is at the start, you usually don't know exactly how you're going to do it either. We do like to see an overview like this, like because you don't want it to be magic. Like you say, so there's lots of pollution in the world. Nobody knows where it comes from. We're going to write software that's going to fix it all. All right, well, that was so little detail about what you're going to do that there is a question of, do you have any idea what you're going to do or what your challenges are? I'd say this is a more appropriate level. Okay, you've broken down your product a bit, how it's going to work, but you haven't gotten sort of bogged down. I had things about partial differential equations in there and correlating with machine learning, and that's probably too much, right? It's a short period of time. Probably I don't really know exactly what approaches I'm going to use yet. That's what I'm going to have to investigate. That's fine. So this is probably a better way to do it. Does that make sense? I don't know if anybody else has an idea of how you might show the solution. This is my idea of a better way to do it than what I did. Okay. And like I said, my favorite way to do a very high level flow chart like this is a mix of a flow chart and then pictures beside it. So this is like a sensor. So that doesn't look much like a sensor, but assume I just drew a sensor and so on, because it's very concrete, not many words. Okay, so any other questions, thoughts about the pitch? Props can be really good. So I'm wearing a mask. So one of the things that would be a good prop here would be kind of like a mask that's a particulate filter, right? So say, when I go out for a walk as a tourist, I do not want to put this on. You put that on, your CI and TA is probably going to remember it. I mean, it's a little bit weirder now because everybody's wearing a mask, so they might just go, yeah, whatever, that's normal. But if you can think of a prop to bring in, it can wake people up, right? You're more concrete. Okay, any other thoughts on that? Okay, if not, I'm going to one of the last thing I'm going to talk about is this is just how do you make things sticky or not sticky? So let's talk about Ebola. I mentioned Blue Dot. It's a real company here in Toronto. So in 2014, there was an Ebola outbreak in West Africa. There were, according to the Centers for Disease Control, 11,308 deaths. There was a 74% mortality rate for confirmed cases. This is a crisis, and the Blue Dot software was used to help plan the response. Okay, what do you think of what I just said? That's like the start. I've actually been at a pitch by Blue Dot where they're talking about their software. So let's say that's the start of their pitch. What do you think of it? Is it good? Is it bad? Is there things you like about it, you don't like about it? I'm going to show you a couple of alternatives, basically. And I want you to just kind of tell me what you think of them. So this is the first one. Did you like it? Did you kind of go, I don't care? Was it okay? What do you think? What do you think? So, okay. And I'd agree with that. I mean, so there's some numbers, so there's some concreteness to it. It's, it's probably credible. I'm quoting the CDC, okay? Is it simple? Not clear. I mean, maybe it's a little too much text, so it's probably not as simple as I could make it. But it's not too complicated. I didn't put a huge number of bullets, and it's maybe credible. You're right, there's some concreteness because I put numbers. So I guess it hits a few of the made to stick principles, but so it's not the worst, but I'd say it's not the best. Okay, so let me give you an alternative. So this is a picture from West Africa. This is a medical worker standing at a child's grave, and the crisis is so acute that she hasn't even had time to change out of her protective gear because the Ebola crisis is that out of control in parts of West Africa right now. What can we do to improve this? Okay, what do you think of that? This is actually how they introduced it. Okay, this was the real start of their presentation. So what do you think? Is this better, same, worse? Any thoughts? Yeah, what do you think? Yeah. So I thought this was a really effective opening. Now, I probably can't do it as well as Dr. Khan did, this is a big part of his work for many years now. But when he did this is like there's a couple hundred people in the room, and it was silent, right, as he went through this, because you can just see with this picture like how horrible this crisis was. So it was concrete. The picture's very concrete. And he can go on to give some statistics after this, but this basically kind of grabs you and you kind of feel it at an emotional level. So it's more emotional, it's more concrete, it really grabbed people's attention. Okay, so that's, I think, a very successful use of emotion. Here's a student, a redacted real student email that I got in 2015. I was shocked and appalled to learn. So you're a professor running a course, you go, oh, what's going on? This sounds bad. That I cannot form a team with my friends in another time slot. Can I? So it's emotional, right? He's shocked and appalled. Was this a good use of emotional? I mean, on the one hand, I remember it. I still remember this email. Was it good? What do you think? So what do you think? Yeah, it's kind of an inappropriate use of emotion. It feels manipulative. It feels over the top. So I remember it, but I remember it for kind of bad reasons, right? I did not put the student like the student essentially like he's asking, can I just disregard the rules that everybody else has because I'm shocked and appalled? And the answer was no, you can't. So I believe in 111, 112, they kind of teach you not to use emotion. Is that fair? Or they've kind of backed away from that? Yeah, so it's interesting. So we have difference of opinions. So I think they're trying to get people away from sort of just making emotional, like, please do it because I really, really want you. So we don't want people doing that. But at the same time, the reality is sometimes emotion is important, right? If people don't care, they won't act. But you have to be balanced. We don't want engineers just making random appeals to emotion with no data, no motivation. This one is inappropriate. The previous one was. If Dr. Khan had basically just presented a whole pile of dry statistics, you actually don't feel or see the people on the other end of them. and it's an appropriate place to see it. Okay, so this is a real research grant that U of T got. So Canada First Research Excellence Fund's a big Canada-wide competition for research money. The universities across Canada put together cross-disciplinary teams to kind of put in big grant proposals. Okay, so medicine and biomedical engineering at U of T asked for $150 million from this, which is a lot. They wanted a big chunk of the national pool, so it's got to be sticky. This is reviewed not just by engineers and scientists, but also by, well, reviewers who will not be in the exact area, and then also ultimately by the minister in charge. So they got to remember it. They forget your pitch, you're gone, right? They're going to a different university. Okay, so here's one possible title. Their work designing molecules, cells, tissues, and organs to treat degenerative disease. Okay, so it's pretty descriptive. What do you think of this title? So, and we're at 10, so if anybody needs, or yeah, we're at 11, sorry. If you need to leave, go ahead. I'm recording this anyway. So I guess I'll tell you, I think this is not a bad title, and it's fairly typical of research grant titles. It says what you're gonna do, okay? It's not the title they used. The real title they used is Medicine by Design, okay? And then underneath that title, they described what it was, which was to actually engineer cells and tissues and organs to treat disease. But they didn't use that as their title. They used a shorter title. And it's simple. It's simple, it's catchy, okay? And this grant actually was successfully funded, which was a big win for the university. Because I think the whole budget for the country was $450 million, and U of T took a third of it, which is hard, okay? Here's a possible, introduction. So researchers in the center will focus on developing new therapies based on design and manufacture, blah, blah, blah. So let's see, read this. Design and manufacture molecules, cells, tissues, and organs that can be used safely and effectively to treat degenerative diseases. The result will be a globally and commercially competitive innovation cluster that, in addition to have positive impacts on human health, will have long-term economic benefits for Canadians by reducing healthcare costs and seizing market opportunities in regenerative medicine. Fairly typical summary from a proposal like this. Okay, here's another option. Okay, imagine a world where a father need not choose which of his two children to save by donating a kidney. Imagine a world where being born with cystic fibrosis is not a death sentence. Medicine by Design will help bring about this world. Which of these are you going to remember? So maybe this is like so what do you think? Do you like one of these better than the other? And I should say it's not completely an either or. In a research grant like this, it's long, so you do get into the detail as you go through. But basically, what would you put earlier? And I actually wasn't part of this grant proposal, but I was part of a follow-on one for essentially machine learning and deep learning, which we were unsuccessful at. And these are big enough that the university brings in consultants to talk to the profs who are writing the proposal. We got like 40 profs discussing the proposal. And these consultants kept coming in and using this as their example and basically saying, you got to tell us a story. You got to get these stories in, or the reviewers won't remember it, the minister won't remember it, you're not going to get funding. So they wanted this kind of story at the start of the proposal, right? As you get further in, you can get more detail, that's fine, okay? So this basically grabs people more. It's got a story, like you're imagining, the story is an imagined story. You're imagining a person going through something, but it's more concrete, it's more emotional, it grabs you more. And yeah, that was part of why this was funded. Catchy title, kind of aspirational goals that were expressed very concretely with some emotion. And the proposal that I was part of, we failed at, okay, we didn't get funded. And these consultants were right. We kept coming up with like, okay, deep learning and lots of data and so on and talking about the details. And they're like, you got to give me a story. Give me something to grab the minister's attention. That's not going to grab the minister's attention. And they were right in that in the end, we didn't get funded. Okay, adapting to your audience. So you always need to adapt to your audience. You have some information that you want to convey. Your audience has some knowledge and some interest, and you need to adapt so that you match what you're presenting to their knowledge and interest. Okay, so what do you think? This is a true statement, okay, but what do you think about how I presented it? Is it simple? Is it concrete? Is it emotional? Did I use any of the made to stick principles here at all? So what do you think? Did I hit any made to stick principle? think I hit some. So what do you think? Yeah, I would say it's pretty simple. Anything else? Okay, so it is simple. Sorry, do you think it gives me anything else? Yeah, it's visual, so maybe it's a bit concrete, right? I mean, you could also argue it's a bit abstract because I didn't give you an example, but you could say, well, the visual maybe makes it more concrete. So it's not terrible. I would say this isn't a bad way to express this. Here's another way, though. Okay, so Kevin Scahill is an engineer that I've known for many years. He's a director at Cisco in Silicon Valley. So he's a very successful engineer. In 1992, he was a new engineering grad. And he's from California. So he decided that before he went on to continue his career as an engineer, he wanted to give something back to the community. So he wanted to teach math in inner city LA. He found this very frustrating. He was teaching grade 12 students. They were not learning. They weren't paying attention to him. And he talked to the principal about it. You know, these students are just not listening. They're not getting it. And the principal said to him, if they're not learning, you're not teaching. And he took that to heart of, okay, the way I'm teaching, which is the way that I learn math, is not reaching them. I need to adapt to what they care about, how they want to take in the information. So he took that to heart. He tried much harder to reach the students by thinking about how do they want to learn, and it worked. It was much more successful. Okay, this is a real story. I mean, the principle is pretty obvious as a story. I still remember this. Kevin told this to me like 30 years ago. I still remember it and try to apply it in my own teaching. So I guess what I'm trying to get across here is actually a story can be very powerful, right? I remember that phrase from Kevin Scahill's principle and try to apply it myself. So, you know, there is a time for showing people this. It's not bad. It can be a good reminder of how you do it. But a story can also, it can sometimes reach people in a way where they visualize the problem more concretely. Okay, this is my last one. So compute density. So there have been huge improvements in computer science and performance over the last 4 decades. The 1969 Apollo computer was 61 centimeters by 32 centimeters by 17 centimeters, so pretty big, weighed 32 kilograms, had a 2 megahertz clock. And a modern microcontroller, so a computer and a chip, from Freescale, there's one that's 2 millimeters by 1.6 millimeters by 0.6 millimeters. It weighs grams and it runs much faster, 48 megahertz. So we've had huge improvements in compute density. Okay, what do you think of the way I've explained this? This is kind of the proud story of electrical and computer engineering, right? Like we've done this, it's awesome. What do you think? Did you feel it? Sort of. You know, what made the stick principles did I use here? Did I use any? So what do you think? Okay. It's concrete, yeah. So it's got lots of numbers. It's concrete. Is it simple? It's kind of not simple. It's got lots of numbers, probably more than I need. So yeah, it's concrete. But you know, the thing is I got so many numbers, I kind of undermine the concreteness. It's hard for you to grasp it. Here's a different way to show that. This is the 1969 Apollo guidance computer. It's more than 2 feet long, weighs 32 kilograms. This is a modern Freescale microcontroller, and yes, it is in the dimple of a golf ball. We get 17 trillion times less volume, and that computer chip is significantly faster. This is an amazing achievement. Okay, so what do you think? Actually, I already told you this. Okay, so I would say, how many people would remember this better or consider this more interesting in a presentation? Hopefully all of you, okay? So this is a lot better. I basically managed to make like what is kind of an amazing story of electrical and computer engineering, something, a bunch of boring numbers that people have trouble absorbing. These pictures get it across right away. So it's more concrete because the pictures, and just saying, you know, the one on the left is about 2 feet long and weighs 32 kilograms, you know, that's enough. I don't need to give a lot of numbers. So it's concrete. It's a bit unexpected because it just seems insane, right? That computer is now more than that computer is fitting in this golf ball dimple. Okay, so that's all I had to say. Fill out the course evaluations. So 9% response rate every year. It's always a challenge for all profs. I'm sure they all talk to you about this, but we really do want evaluations so we can get better, right? So most of us are here teaching because that's important to us, so we want feedback. CIs and TAs also want feedback. It's very helpful to them. So it's a form on Quarkus. If you can fill it out, it's much appreciated. Okay, thanks everybody. And I'll hang around in case you have any questions, but yeah, we're out of tutorial time, so I want to let you go too.